Hi, this is Dr. Kimi Sato. In this lecture, we'll talk about the speed and agility development. This is very useful not only for the track and field sprinters, but also the field and court sports athletes to be able to have that change of direction ability. And the first lecture, we'll talk about introducing a concept of speed development. And here, we'll talk about the biomechanical factors of speed development and then also how weight training affects the speed development. Let's talk about how to understand the sprint biomechanics first. So, first one, the fast sprinters produce more than 3 times the body weight at each step. What that means is when you actually land on the ground, you push off that force about up to 3 times the body weight. And of course, it's up to 3 times, so it doesn't have to be 3 times. So you might have a double the body weight to push off, and then as you develop the speed, the ground reaction force gets more and more. The second one, the swing time between average and elite sprinters is about the same. And then this is actually an interesting data because people would think that the elite sprinters have faster turnover time, meaning that the swing time is shorter, but the research shows that the average and elite sprinters are just about the same for that swing time. Next one, the high force quickly allows elite sprinters by longer stride. And what that means is the high force that you can produce a lot of force to the ground, propel yourself forward, and you have longer coverage of the distance. And then this also kind of makes sense that if you actually have a higher ground reaction force, you can push yourself forward. And then the last information, the sprinters only have anywhere from 0.08 second to 0.11 second on the ground contact. And then if you think about this is such a short time of the window, and what sprinters have to do is to produce enough force in such a short time period to get yourself forward. Another part to understand the sprint biomechanics is the motion of the sprinters. So fast sprinters produce force at the optimal position to strike the ground. So what that means is when you actually hit the ground, you have to have a very good aligned joint, and your hip and then pelvis position have to be neutral. What that means is when you actually hit the ground, if your pelvis is anteriorly tilted or posteriorly tilted, it's very hard to transfer the energy to the ground. And also, when you actually hit the ground, you have the flex hip position leading to the high knee. So when you're running, you have to have that flexion of the hip coming in so you can actually get your knee high as you take off. So if you have your hip extended, very hard to get your high knee, of course. So you have to have that natural transition from extended hip to flexion of the hip joint. And then finally, when you actually hit the ground, if you hit the ground in front of your body, that hits the brake. So you have to hit the ground underneath your body so your momentum keeps going. Oftentimes, I see this from especially the junior athletes, the sprinters. They actually hit the ground in front of them and then hit the brake. So you have to recreate that momentum. So some of the drills that we introduce is to get that foot landing position underneath the body. Let's talk about the weight training effect. So there's a big misconception about the weight training time equal to bigger muscles by coaches, and the bigger muscle creates athletes to be slower. That's the kind of conception people have. So what we want to do in the weight training is we don't necessarily have to develop the muscle mass, but we have to create the muscle to produce high force, but also high force fast. So some of the things that we have to encourage people to do is to develop the muscle the way that the sprinters would need. For example, if you do a whole lot of heavy weights in a slow speed action in a weight room, that's actually to create a muscle force and also creates a hypertrophy. So you have to combine those exercises with relatively light weights but the fast speed to gain the muscle contraction speed. In other words, your muscle fiber have to contract really fast from the neuromuscular effect. Then you can actually have muscles that's gonna be very good for the sprinters to be able to run faster. And also from the approach to weight training, it's a little bit different from other athletes. So what we want to do for the sprinters or some of the field and court sports athletes who needs to develop the speed, we have to take a step-by-step approach in a weight room. So the first step, we have to do some weight training to build the engine. What that means is building the stronger muscles to be able to produce high force. The second stage of the training, it's almost like a fine-tuning your engine, meaning that your muscle that you just developed have to have a faster contraction. And then driving skill is the last one, meaning that the technical improvement. Once you develop enough force and the contraction rate, then you can work on a technique to actually transfer what you did in the weight room down to the performance side on the track or on the field or on the court. So this is very important step-by-step approach to have that block periodization to train your engine, fine-tune your engine, and develop the skill. In this lesson, we're gonna cover most likely to have a series of acceleration development and then maximal speed development, and then we'll talk about the agility and quickness development. And then again, you have to have this step-by-step approach in a weight room, and then also the skill-wise, it's the same thing. You have to develop the acceleration and then the maximal speed, and then transfer to agility and quickness.